In this question, we're being told that angle OAB has a measure of 30 degrees. We're also being told that segment OC has a length of 18. So the next thing we can think about in this situation is the idea that all radii of a circle, all radiuses, are congruent to each other. So if I know the length of one radius, I know the length of them all. If you know OC, then you know OA and you know OB. That's actually really important here because if OA and OB are congruent to each other, then that's an isosceles triangle. And for isosceles triangles, the idea there is if you have a triangle and two sides are congruent, then you can assume that the two angles across from those sides are also congruent. So this angle would be congruent to this one. And notice that isosceles triangles have some symmetry. So in our situation, knowing that this is an isosceles triangle allows us to say that angle B matches angle A. They're both 30 degrees. Now that triangle ABO, has to have 180 degrees in it. So if we already know that two of the angles account for 60 degrees, then we can assume the third one is 120 degrees to make sure that all three angles of the triangle add to 180. So now that we know that we've got a 120 there, that kind of changes everything. The reason is because, let's just imagine first that we've got a triangle without so much stuff going on. But if we have that 120 right there, let's draw this a little better. So the reason that 120 degrees mattered so much was because it tells us the fraction of the circle. We just found out that that pizza slice there is 1/3 of the circle. Because if we're dealing in the degrees and the angle of the circle, we now know that the part over the whole for what we're dealing with is 120 degrees out of 360 degrees. In other words, it's 1/3. And what happens with fractions of a circle is that whether we're talking about the angles or the arc, which is a piece of the circumference, or the area of a pizza slice, which is a piece of the overall area, the fraction will remain the same each time. So right now we are looking for arc AB, which is a fraction of the circumference. So if our part over our whole for this circle equals 1/3, in other words, we're dealing with 1/3 of this circle, then that has to equal the arc we're talking about over the whole circumference of the circle, which we know, by the way. We know that the circumference of this circle, if it's 2 pi r, then it's 2 pi times 18, because we were given the radius from the beginning. So we can put 36 pi there. So what we're saying is that this 1/3 also pertains to that arc out of the whole circumference, 36 pi. So now we can cross multiply that, and we can get 36 pi times 1 equals 3 times x. Divide both sides of that by 3, and we'll get x equals 12 pi. And we just found out that the length of arc AB is 12 pi.